Okay, they're given the velocity function, and it's in meters per second. They want you to compute a couple of things. Certainly want you to displace it over 0.6, which generally speaking is pretty easy to do, by the way. The way I like to do it is I like to get what's called the position function, st, and that's done by integration. The integration for this one is fairly simple to do. I don't know what the constant is, and I'm not interested in finding it. What's displacement? It couldn't get easier. All you have to do is do the subtraction S6 minus S0. Let me write that down for you. So S6 is going to be 6 to the fourth power over 4 minus 10, 6 to the third power over 3 plus 12, 6 squared, and then plus C. And S0, oh gee, that couldn't be easier, could it? You can get 0, 0, 0, you just get C. So what do I know about that? S6 minus S0. The C's disappear, and I'm left off with this computation here, all right? I'm going to factor out a 6 squared on that, all right? And what would you be left off with? Well, you left off with 6 squared over 24, I'm sorry, 6 squared over 4. 6 squared is 36. 36 divided by 4 is 9. Minus, well, you factor out 6 squared, so you're left off with 60 over 3, which is 20. And then you're going to get 12. Well, isn't that convenient? Because 9 minus 20 plus 12 is just the number 1, and 1 times 6 squared is 36. So I'm in agreement with that over there. Some students are also going to do this by integration. What do I mean by that? A definite integral. Not the indefinite one, but a definite integral. They're still going to get 36. All right? So if they did it this way, you're still going to get 36. All right, that part's done. Next part is much more difficult. All right? And what I mean by that is that there's the velocity is changing. It's going from positive to negative. So what I'd recommend you do there, again, it's more difficult even to think through it. The velocity function should be factored. That's a relatively simple factorization problem. All right, so I just want to draw a picture of what the velocity looks like. And there's really 3 places where it's stopping: at 0, at 6, and at 4. And I just want to talk about the velocity. Is it moving left or right, up and down, yeah, blah, blah, blah. Positive, negative, which I'm going to boil it down to. I'm not going to bother going below the 0 or above the 6, right? Because they're only talking about between 0 and 6. So if take a test point to 0 and 4, and a good test point to take between 0 and 4, I would say would be 1, and you're plugging it in. Whoops, sorry about that. Let me erase this over here. You're plugging it in here. So if you plug in 1 there, what would you get? You'd get positive, negative, negative. It's positive. What does that mean? If I'm moving in a left or right direction, it's moving to the right. Now between 4 and 6, if you chose 5, where do you get positive, negative, positive? So it's negative. So what do I have to do? Well, I got to get that S function again, and then do the distance that it travels. All right. So let's just talk about. There's 2 cases. The case when it's moving to the right, that's between 0 and 4. That's this case over here, which can be S4 minus S0. Now, as it's going to the left, what do you get over there? It's going to be S6 minus S4, right? What do you get over there? A negative number, as you'd expect, right? What's the distance going to be, though? Again, I want to point out the distance is going to be 128 thirds. Now, this guy's distance is 20 thirds. I don't care what direction it's moving in. It's a distance. What do you get over there? 148 thirds, which you have over there. Another way of doing this, for students that want to do the integrations right over here. There's trouble with that integration, though. Why is that? There's an absolute value. You're still back to rewriting the integral, so you get rid of the absolute value symbol. Are you still going to get 148 over 3? Of course you are. Thank you.